Hi, my name is John.
And my name is Alice. You're watching Math Videos for Parents. We help you so that you can help your kids with math. And John, we're continuing our series on fractions. Today we're talking about generating equivalent fractions. So I'm going to start by just taking a look at that image on the left. If I were to write this as a fraction, this one here, I would just count how many parts it's divided into. And I'd say, okay, that's 4 parts. That's going to be my denominator. And then I would count how many are shaded. And I've got 1, 2, 3 shaded parts. So I'd say, okay, the shaded portion is 3/4 of the whole. Now, John, from there, I understand we're going to learn how to generate equivalent fractions.
Correct. So perhaps as a learner yourself, you might have heard the phrase reduce fractions or simplify fractions. In the language of the Common Core, we tend not to use those at least the word reduce, because that implies that we're making the fraction smaller, which we aren't. We're just coming up with a different way to write the same exact fraction. So the language that is typically used in your child's math class is generating an equivalent fraction. And there's two ways that we can do that. We can do it through multiplication, which is the topic of this video, and then division, which will be the topic of a later video. Now, the idea is this. So if we look at the shape that Alice just described versus the next one, we see that the amount of gray area is the same. Visually, the percentage of gray in both of those two images is the same. However, what happened was, from the first image to the second image, we doubled the number of rectangles. Instead of having 4 rectangles total, we drew a line right down the middle here to create now 8 rectangles of equal size. And of those 8 rectangles, I seem to have twice as many now that are shaded. So the amount of shaded area that I have would be 6 out of 8 little rectangles. What do you see in yours for the third one, Alice?
So, one thing I'm observing, even just from going from the first to the second, as you just showed, John, is we did that graphically, but we could have done that by multiplying. So, if I didn't have an image to help me, I could say, okay, 4 times 2. And then what we do to the bottom, we have to do to the top to keep things equivalent. And I could have done, okay, 3 times 2. And that also would have given me 6/8. So another thing I could do if I want to generate this as a fraction and I don't feel like counting things is I could take my original 3/4 and I could say, okay, I guess I do have to do a little bit of counting, which is fine. I can see I've got 4, 8, 9, 10, 11, 12 squares total in this fraction. So I'm going to ask myself, well, what do I need to multiply 4 by to get to 12? And that would be 3. And again, what I do to the bottom, I have to do the top. So I do 3 on the numerator as well. And that would give me 9/12, which would indeed be this fraction here.
Perfect. And we would say that's an equivalent fraction to both 3/4 and 6/8, since it's the same total shaded area that we have, but we're just parsing it out differently. The size of the rectangles each time is a little bit different, but the total that they make up is all the same, and it's all about 3/4 of the whole area.
You know what this reminds me of? This reminds me of my husband and I. We have 2 different dressers, and they're the same size, but I like a lot of drawers, and he likes fewer. So I have 2 drawers full of T-shirts, and he's got 1 big drawer full of T-shirts. But we actually have the same amount of space devoted to T-shirts.
Exactly. Maybe it just separates better for like work and not work or something like that.
Exactly. Yes.
All right. So maybe we
Okay,
can look at
wonderful.
an example where there's no pictures, which is also common. So how will we go about generating equivalent fractions without a picture? So if I have something like 4/5 or 4/1/5, you can kind of say it however you want. Other equivalent fractions I could get are by just taking 4/5 and multiplying on the top and on the bottom by any positive number you want. So one example could be, let's say I multiply by 4 on the top and on the bottom. One a little bit bigger for this one. That would give me out 16/20, which is equivalent. And again, you might have seen 16/20 as a non-reduced fraction or like a non-simplified fraction, but it's just, we want students to understand this is equivalent. This is taking a shaded area and just expressing it in a different yet equivalent way. One other one, sometimes with working with percents, it's helpful to have things taken out of 100. So a student might have to generate a fraction with the denominator of 100. So if that's the case, we can multiply the top and the bottom, say each by 20. And another equivalent fraction I could get is 80 out of 100. So maybe a teacher's grading a little quiz and the teacher gives the student 4 out of 5. That's the same as getting an 80%. So there's lots of good connections there too.
Okay, great. So I'm going to tackle the bottom problem, two equivalent fractions for 5 over 4. So the first thing I'm going to do is say, well, I'm going to multiply the top and bottom by 2. So that would give me 10 over 8. And then I want to generate a second equivalent fraction. So I'm going to say, okay, I'm going to multiply by 10 top and bottom. It's always quite easy to multiply by 10. So that's going to give me 50 over 40. So 50 over 40, 10 over 8, they're equivalent fractions to 5 over 4. John, I was raised to say reduce, so I'm glad you mentioned that that's, something that, a term that is kind of being phased out. So now I would say, okay, these are equivalent fractions to 5 over 4.
Yep. That's exactly it. So again, the word equivalent is a word that might seem scary for younger students, but it is the word that's used as they move all the way up into high school level algebra and beyond. They will see the word equivalent instead of a set of procedures or directions, because that gives students this false understanding that they're just doing a list of operations for the sake of doing it. So we just stick to equivalent so that they understand that we're just taking something and rewriting in a different yet equal way. So if it's possible when you're working with your young learner at home to use the word equivalent, that'll be good for lasting conceptual coherence.
Excellent. Wonderful. Thank you all so much for watching. We hope you found this video helpful. Please reach out to us if you have any topics you want us to cover. We look forward to helping you more in the future. We're Math Videos for Parents.
Have a great day.